Hello, ladies and gentlemen, our future engineers of the world. My name is Charles Kelly. I'm with the National Society of Black Engineers, NSB DC Professionals Chapter. And today we're going to be talking about the Bernoulli Principle. The Bernoulli Principle studies the effect of velocity on air pressure and basically states that at a higher velocity, you're going to have a lower air pressure, and at a lower velocity, you're going to have a higher air pressure, which is responsible for a lot of things in our daily life. One being air travel, something that's always boggled my mind, how this huge vehicle carrying a lot of passengers makes its way into the air. And that's solely determined by the way things are structured. So let's get into it right now. Okay, so you don't need too much for this procedure. I'm going to be using some soda cans. You're going to see all this in the PDF that is sent with the project. Measuring tape or a ruler, scissors, some tape, string or ribbon. Okay, so as you see here, I kind of have a makeshift setup, but if you are able to stand the cans up higher, kind of above your chest length, or if you have a curtain rod that you can use, but what you want to make sure is that the air can freely flow through. You don't want something to be on the back end of the cans to reverberate the air. And you want to make sure that the cans start at about 12 centimeters apart. And I measured all that out, and we're going to start the fan on low, and we're going to get the results. I'm going to need my stopwatch, and we're going to tally those results into a table. All right, guys, so two things. We're ready to go. I wanted to point out that I ran into issues with, you want to make sure that the fan or your blow dryer is going directly in between your cans. And also you want to make sure that the cans are absolutely at 90 degrees and as vertical as possible to avoid one being slanted, and that's going to cause a change in your results. So here we go. We're going to start the fan on low and measure the amount of time that it takes for the two cans to collide and mark that in our tables. So I'm using my stopwatch for this, but this is for show. Okay, now we're at the data collection point. So we were originally at 12 centimeters. We have spaced it out to 13. And we're gonna run this. We're gonna run each distance for about 5 times. So you got 5 at 12, 5 at 13, and you just wanna keep on going until your cans don't really collide. And then we're going to repeat that at 12 and go with a higher speed. So higher speed at 12, higher speed at 13, and you just want to collect the data sets, and I'm going to show you in a table posted here how you can lay your data out to get your averages and show the effects of pressure on your two cans. Yeah, so I hope you guys all learned something today, or just further refine your skills for testing about the effects of pressure with velocity. And I'm going to attach another video that just kind of gives you some more examples of how this applies to your everyday life. Combustion engines, fluids flowing through your vehicle, through your house, baseball, so fluid dynamics is used everywhere, pretty much anywhere you need to move matter and mass. So thanks for joining, and I hope you guys are able to put together your information and learn something new today. All right, enjoy.